In this video, we will look at how to write quality programming using the four important concepts of object-oriented programming concepts, which are abstraction, encapsulation, inheritance, and polymorphism, using Dart programming language, which is used in Flutter, but the same concepts are also implemented or could be implemented in other object-oriented programming languages such as Java, C#, C++, Python, and other languages. First, we understand the concepts, and then we will look at how to implement them in while building an app. So let's first go with the first one, which is the abstraction. Abstraction, basically what it says is you try to hide the complexity of the code and just expose the features which are needed. In other words, you only show the features which are needed while hiding the complex implementation part. For instance, we use in Dart something called stateless and stateful widgets. So we access the stateless or stateful widget without knowing how those widgets have been implemented. In other words, how the content has been written and implemented. So the second concept is known as the encapsulation. This is very similar to a capsule you might have seen, like when you go to the pharmacy. Here what we do is basically all the internal private content, you basically keep it inside and you only expose only when it is needed. For instance, if you see a variable with underscore current index, so underscore is something that in Dart programming we use to say that this is a local or internal private variable. And the same thing, for example, here if you are creating a local widget variable underscore pages, so these are basically are encapsulated inside another state, for example main page state, which cannot be accessed from outside the class. When we try to do the implementation, you will understand the concept better. So from outside class you can't access these private variables or private features, in other words. The third concept of object-oriented programming is known as inheritance. This is very similar to the parent-child relationship or father and a son relationship, where the children inherit the features of the parent. The children inherit the features of the parent. Now here, for example, a class can inherit the behavior and the properties of another class. For example, here the private feature, which is again annotated with underscore at the beginning. So what it says is that this particular state, main page state, this class can inherit its parent, which is the main page. The fourth concept of object-oriented programming is known as polymorphism. Now here poly means many, morphism, many forms. This, to give you a simple example, if you have a class, for example vehicle, and a vehicle is a very generic behavior, it's like a parent, or sorry, it's like one of the class where it's a superclass, we call it as a superclass. Now vehicle can be a superclass, but under the vehicle you can have many sub vehicles, for example Toyota, Nissan, Ford, and so on. So these different forms can have their own specific features. For example, Toyota might have features specific to Toyota's based vehicles, but they all come under the concept of vehicle. So that's basically what polymorphism is, where you make a subclass with different behavior whenever a superclass is expected. Now let us see this in action. So I'm going to open up the VS Code. I'm going to start creating a new project, view, command palette, or Control Shift P. I'm going to select Flutter, new project, and here I'm going to select application, and I'm happy with this location, C drive and apps. I'm happy with this one where I want to create the project. So because we are creating this project is about object-oriented programming, so let's basically call it as a basic structure Flutter app, say object-oriented programming concept or object-oriented programming. Oops. So I create this project. Now the project Flutter app is being created for us. Now unlike the way we can write the code in 100 different ways, but now I will try to show you how to write a structured programming that is qualitative, easy to maintain, easy to read, and easy to look after it on a long term basis. So first things first, I'm going to delete this piece of code which comes with the default. I'm going to import package, import package Flutter. Sorry, there's something wrong here. Let me see. Hang on a second. Import package. There you go. I started getting the intelligence now. Flutter material dot. This is the basic package that is needed to build any Flutter app applications. Now void main. This is the main function. That is, see, as soon as I write main, you will see the options there: run, debug, profile. That is automatically generated. It's not me who has written that. So now I'll basically point to the run app, and I'm going to make a call here to my new app. Okay, so I will name this app as, say for example, my app. Okay, and now we need to implement that my app. So basically what I'm going to do is class my app, which we have given the name. It could be my app, it could be any name, it doesn't matter. Extends. Now for this demo, I'm going to use the stateless widget. As we know that there are two types. One is stateful and stateless widget. Stateless widget, if you know that the user interface is not going to change. If it's going to change at runtime, then you need to use stateful widget. Okay, so stateless widget, I'm going to open up and close the flower bracket. First I create the constructor, and we need to give the same name of the constructor as the name of the class here, as you can see. Okay, let me increase the font size just to make it look better. So appearance, zoom in. Okay, now what I'm going to do, it's my app, that's the name we gave, constructor. So we are creating a constructor with all the parameters that's needed for the super key. So super.key. So that's the first thing. Now here normally what we do is okay, first we will create the override. Let me continue with this one. Override, and there you go. So that's the widget build context. Now here I'm going to return material app, and as we know that we need to specify the home. Okay, now what I'm going to do is, for the sake of this demo, I'm just going to specify it as null. Okay, null, and we are getting this error because we forgot the semicolon here. So I'm going to put the semicolon next to the constructor. That's the reason we got it. And I'm going to delete this comment, and I'm going to, again, I forgot the semicolon. That's the reason it's giving that error. Now, so what we have seen here is basically we have written the main file here in the main, where we are making a call to the run app. Basically it invokes the my app. It could be my app, or it could be whatever you want to write it. Say for example your demo app, etc. Whatever the name you write here, the same name should be specified here. So all it is doing is we are basically calling the basic structure to open up an app, and in this app we are calling the material app, and here we need to specify what is the other piece of code that needs to be shown in the home page. I mean, if we run this one as is, I will just save this one. I'll try to run it. It will not do anything. I'll use the Microsoft Edge, and I'm going to put this on my left screen, and I'm going to show the output in the Edge, Microsoft Edge. You can use the emulator, you can use Chrome, you can use any other output. It's totally up to you. So it's waiting and run. Let's let it launch. While it is launching, let me try to create another page while it is launching. So I'm going to create another page called home page. So the logic we need to write for the home, instead of writing it in the main file, we can write it in the home page dot. Now in that page, let's try to create this page where we are going to implement the 4 important principles. So import, again same thing, we need to import the package Flutter and material dot package, and class we will call it as, say for example, the home class, home page. So we will call it as a home page. So it is loading. So there you go, it has loaded. So this is basically the output on the right side. As you can see that there is nothing here because we basically specified the main as null. That's why nothing is coming out there. It's fine. Let's first continue writing the second page, that the home page we have started writing. So first we create the home page, and again it extends. We can make it as stateful. As I said, we have stateless and stateful, because we know that it's going to we need to make some changes. So that's why at runtime, let's try to make it as stateful widget. Create the constructor const homepage, whatever is the name you have given here, the same name should be given there. So, and then the super keys, super.key. So this is basically the first thing. Now here what we are going to do is override again widget state of homepage create state. Now I will try to explain you this in a minute, just bear with me. So here what we are going to do is we are going to make a call to the internal private class, so which is basically part of polymorphism and encapsulation concept, which is basically I'll put underscore homepage state. Okay, now we need to create this. Sorry, I forgot the semicolon again next to the constructor, and now it's saying that this one is not found. It's fine. Now we need to create a class underscore homepage. Now you will understand what is how this encapsulation and polymorphism works all together. So extends state of homepage. Basically whatever is the state of homepage, if it's a private, it will be private. If it is public, it will be public. That's basically what it means when we are writing this in brackets like this. Okay, now you can write all the code here. For example, we can write some small piece of logic here. For example, final string. Let's create a string. Now please note that I'm providing here underscore. As soon as you put underscore, means that is accessible within this class, it cannot be accessed outside. Okay, so underscore app name, for example app name, my you can call it as, for example, my beautiful app, for example. Okay, and then we can also get the current date or time, something like, let's go for it. Say for example underscore final date time. You can even specify what type, it's a string or whatever you want to display. It's totally up to you. So for example date time dot now, that will give us today's current date and time as we are running this one. Now let's create a widget. Okay, sorry, again override, override widget build. Now in the build context, because context is basically a reference pointer, that this code has to be implemented at the reference where it is located in the tree, in the widget tree, which I will show you in a minute as well. Now for example, I just wanted to return here something. For example, return text, for example, some text here, welcome. And I also I also want to reference this local variables, which are private variables. Then the way you do that in dot programming is you provided the dollar sign, and then you can specify whatever is the name of the variable. Basically, in other words, whatever you have written in dot code, what was the name we gave? Underscore app name. And you can also continue writing and specifying the date. Today you access my app or something like that, access or time, date and time. You can just specify again dollar underscore date time, whatever is that one. So as soon as you specify the dollar here, it means that you can write the dot code here now. So underscore date time, that's the name of the variable we gave here. Okay, so and then I'm going to provide this one and put like this. So I'm going to close this one here. So basically this is a small piece of code that we have written. So basically what we have done is here, this is the concept of encapsulation. Okay, encapsulation. What does encapsulation means? Like you hide all the complexity internally. Like that's basically what encapsulation. If you see here, encapsulation, keeping internal state private and exposing only what is needed or when it is needed. Okay, so now that's the concept of encapsulation. We wrote all the logic here, and we are basically exposing this logic underscore homepage state in here. You see there, that's the encapsulation concept. Now also you can understand that this one is an example of abstraction and polymorphism as well. How? I'll show you. So this is basically an example of polymorphism. Now, what did I say in the polymorphism? As you can see here, polymorphism is you make a call to the subclass. As I said, you can have a vehicle class and you can have so many children classes. It could be like, Toyota class, or Nissan class, Ford class, Ferrari class, and so on. In our case, what we are doing is we have the home page, but inside the home page we are making a state home page state. You can even create another class here. Instead of home page, you can call it as, say, settings page state. You can call it as for example, about us page, contact us page, and so on. And you can basically create this one, say polymorphism, many forms. So basically here you are referencing this to a particular child. All the features of that child you can basically modify and you can display here. This is the example of polymorphism. Okay, now abstraction, again, that's another concept that we learned. Abstraction show only the features needed while hiding the complexity of implementation. Now in our case here, this is an example of an abstraction here. Now how basically this particular feature, a home page, it is extending the stateful widget. So now in that, basically like here in the abstraction, as it says, you see here, if this particular, for example, only the features needed while hiding the complex implementation. How this particular complexity here it is implemented, what is the code, everything, all the complexity is somewhere else. You are only exposing. And the same thing here as well. For example, home page is extending stateful widget. If you want to see what is written inside the stateful widget, you can just press the control and click that link, and you can see all the code that is written there. You see, this is all the code that is written in the stateful widget or stateless widget. We don't need to know all this stuff here. That's basically what abstraction. We are only accessing the feature of stateful widget, extending it, and abstract. That's an example of abstraction. So we learned the concept of abstraction, polymorphism, encapsulation. Now I'm going to save this code. Now still we haven't got anything here empty because we haven't made a call yet. So here in our main class, what we are going to do is, instead of we wrote the value as null here. That's why everything is empty. Now instead of having null, let's make a call to the home page which we have created, which is the home page, home underscore page, but the name of the class we have given is home page. So we need to write here home page. So home page. Now as you know that as soon as we write here, notice what will happen. So as soon as I write, for example, I'll just show you again. Look at this home page. As soon as I click here, you will notice that the import link for that reference will be done. You see here. Otherwise, you will have to do it manually. Import package Flutter app, whatever the name of your project, backslash homepage dot, because it's saying that literally that this particular class that we are referencing here, it is located inside this, and that file needs to be referenced in the main class. So if I because now that we have made here home as the home page, let us just save it, and you will see now that something will be coming there. So there you go. Welcome to my beautiful app or something, date and time. That's basically what we did to make it look a little bit better. What I'm going to do is make it look at the center. I'm going to wrap this one text. I just click on this text and then click on this yellow bulb and wrap with center. So if I save it now again, and now you will see that in the center here. So I hope that's clear now. So basically what we have done is, this is a very this is a structured programming using object-oriented programming concepts. So to give you an example again, this one here, here is a concept of inheritance concept, where the child is inheriting, it's extending stateless widget. See, we have used the same concept many places. So if you go back to the slides, inheritance, as I said, a class can inherit behavior and properties from another class, just like the parent-child relationship. So here this my app is extending the stateless widget, so it is also inheriting the features of stateless widget. So that's basically what inheritance is. So that's basically the 4 important concepts, and that is how we write the quality programming. And this is very easy to read, maintain, even on the long run. I hope that's useful. So this is basically the main page what we got. If I save it, and if we got the home page, and that's basically, this is basically what we have in the home page. So and this is the standard structure that we should be following for any project. Whenever you are trying to write a new project, make sure that you follow the same standard. So basically the way the system begins is, it begins from main, and from the main it goes to the my app, and the my app says that, you know, I am basically building a material app or design based on this home. What is the home page? Now if you go to the home page, you can go from here, or you can even control press here, it will take you to the location in that page. So in the home page, you can see that in the home page again we are saying that this home page is designed based on the polymorphism concept, which means here it is home page is extended to the internal class. When it comes to the internal class, that's where basically this is the actual content that we are seeing in the home page. Now again, tomorrow you can write another internal state, home page state. You can have another, for example, like this class class underscore, say for example settings state, like this, and so on, extends, and the same thing just like the way you have here. So in this way you can have many children. That's what polymorphism concept is all about. You can have multiple children, but you only make a call to the child that you want to display. I hope that's useful. Thank you.